Now let's take a look at our celestial companion. In the Standard Model, the Moon is thought to have somehow been formed from a collision of the young Earth with a massive asteroid or small planet. This unconvincing scenario results once again from the absence of a repulsive force in gravitational astrophysics. The Moon is said to have formed from widely distributed, blasted-out material. The standard explanation for the asteroid belt between Mars and Jupiter is that due to Jupiter's gravity, no planet could form from the rocks, but it is said to have been possible in the immediate vicinity of Earth. The asteroid belt gives the impression that a small planet has been completely destroyed when a larger one approached. It is possible that the same celestial body that once devastated Mars was responsible. In the all-electric cosmos, there is only one way the Earth got to its moon. It was caught. Electrical interactions between the two celestial bodies stabilized the orbit of the new satellite. Such an electrical stabilization of orbits is probably the reason why the solar system with its many objects does not fall into gravitational chaos. It has long been known that no system of three or more mutually attractive objects can be stable. This is called the gravitational three-body problem. After a short time, at least one of the three bodies is catapulted out of the system. There are abstract mathematical solutions to the three-body problem, but they have nothing in common with the observed, ordered elliptical orbits of the solar system. Gravity alone cannot explain the shape of the orbits or the stability of the solar system. The electric model claims electrical interactions between the planets and with the solar wind. The charges of the planets, and thus their gravitational and repulsive forces, are balanced in such a way that the orbits remain stable. In the all-electric conception, gravity might only be a secondary phenomenon that depends on the electric charge of a body. On Venus, the electrical interaction with the solar wind can still be clearly seen. Its magnetosphere, that is its local plasma bubble, is elongated like a comet's tail. It reaches all the way to the Earth's magnetosphere. The typical filamentary structures of Birkeland currents have also been discovered in this tail. The Venus tail is made up of many small, thread-like things. The theorists will have fun explaining why they are so skinny. Venus still exhibits a strong interaction with the solar wind today. Consequently, it has the most circular orbit of all the planets. Another clue to the electrical nature of orbits comes from new observations of asteroids. This is the asteroid Ida, which is about 55 kilometers long. It has a tiny moon called Dactyl, which orbits the asteroid at a distance of 90 kilometers in a stable orbit. According to gravitational cosmology, this should be impossible, since Ida is not a spherical body, but has an elongated shape that must lead to an uneven gravitational pull. Therefore, a stable orbit should not exist. Even the capture of the small moon cannot be explained by a merely attractive force such as gravity. Ida isn't the only asteroid to have a moon. In 1999, a 13-kilometer wide moon was discovered around the 215-kilometer wide asteroid Eugenia, orbiting the misshapen boulder at a distance of 1,190 kilometers every 4.9 days. The 140-kilometer asteroid Pulkova has a 20-kilometer moon at a distance of 800 kilometers. The Antiope asteroids were initially thought to be a single object, until it turned out that they were two asteroids, each about 80 kilometers in size, orbiting each other. Recently, even asteroids with two or more moons have been discovered. All these objects are unlikely to exist in gravitational cosmology. They clearly show that we do not understand the origin of planetary and lunar orbits, and that gravitational models are once again being put under severe pressure by new observations. Back to our beautiful companion. Like Mars, its surface is divided into two distinct hemispheres. On the side that is always facing Earth, there are extensive dark areas, the seas or maria. On the backside, though, there are no such areas. Obviously, the Earth is responsible for the maria, but in the gravitational models, there is no way for the Earth to affect the Moon in such a way. Massive electrical discharges, though, may have initially covered the Moon with craters. We see the typical features of such electrical discharges. Shallow craters with steep terraced walls. Craters with one or more rings. Central mountains. Chains of craters and grooves. Since the interaction between the Earth and the Moon was not just a brief encounter, but a very close, permanent relationship, the Earth's electric lasso could have caused the Moon to lose its independent rotation. We have been facing the same side ever since. The plasma lasso probably burned its traces into the lunar surface in the form of the Dark Maria. As observed at the end of 2010, craters at the Moon's south pole are still showing electrical activity. Of course, in the all-electric cosmos, it is the poles where plasma discharges preferentially occur. On Earth, we see this in the form of the aurora. On the Moon, which lacks a protective atmosphere, the electric currents penetrate to the surface and cause the craters to glow. These craters at the south pole of the Moon are also interesting because of their number and size. The initial electrical exchange between planets, guided by their respective magnetic fields, will be focused on the polar regions. On Mars, for example, this can be seen in the fact that the area around the South Pole lies about 2 kilometers lower than the rest of the southern hemisphere. On the Moon, there are particularly pronounced craters at the South Pole. And just like Mars, the Moon also has a clear division into plateaus and lowlands. Furthermore, the area around the south pole of the Moon lies lower than the surrounding area as well. Since the rocky bodies of the solar system show so many traces of electrical interaction, similar traces might be found on Earth. Next, let's take a look at our home planet.